Hello everyone, it is a nice sunny day in Keynsham. I'd love to show you but I can't, this is a screen capture. But when it is sunny, especially in Keynsham, I like to code if statements. And I'm hoping that one day, wherever you are, you will too. So what is an if statement? Well, as you can see here, an if statement is part of a series of statements called control flow statements. Now normally what happens in code is your commands will be executed from the top of the source file or the page to the bottom. So for instance, if you have 4 print commands, the one at the top will print first, and then the next, then the next, and then the next. Now a control flow statement is slightly different because it breaks up that natural flow of execution where decision making, looping, branching and so forth is concerned. So that means that some parts of your code will be skipped and some parts of your code will repeat. So let's jump into some to have a look. So you remember from our last video we looked at some comparisons. So for instance we looked at this where we had an operand on the left, an operand on the right and an operator in the centre. So this here I've resolved as true or false. So this one resolves as true because 5 is less than 7, that's true statement, and this one here, 9 is less than 3, would resolve as false. So these become the conditions of our if statement. So let's jump into writing an if statement. So I'm going to type if, and then some parentheses. So I type on the left one, the right one automatically is typed onto the screen. Now within there, we're going to write a condition. So the condition is this: 5 is less than 7. Okay. Then an open brace. So it's the first time we've seen this symbol at the moment, but this usually is to the right of the P on the keyboard. You might have to press Shift for it to print. Okay, and then so once you've done the left one, if you press Return, the right one should be automatically generated. And you'll find also that you get a nice indent there in the center of your if statement. So now I'm going to put system.out.println and then some text. So this is a true condition. Okay, so this is what's happening here. If this condition here resolves as true, this code within the braces will be executed. So I'm going to hit that and it works. So you can put as many statements in there as you want. So I can put system.out.println and then some more text. And when you run that, both will execute. So can you put anything you want in here? It could be additional if statements. We'll be looking at in a couple of videos' time. Those are nested. Or it could be loops, whatever you want. Anything will run within these braces here. Okay. So usually what we do is we don't have hard-coded things within the if statement. Because if that's hard-coded, then there isn't any kind of condition. This will always resolve as true or false. So I'm going to declare 2 variables. The first one, A, initialized with a value of 6, and an integer B, initialized with a value of 6 again. So let's remove what's in the condition already, and I'm going to put A equals B. So the condition in this case is if variable A is the same value as variable B, then the code within these braces will print. So this will print. Now both are 6, so this is a true condition. Going to hit run and you get both there. Now if I change that to 8, this condition is no longer true, it's a false condition. So 8 is not equal to B. Nothing will run. However, there might be a case in your program where you actually want something to run when this condition resolves as false. And you can achieve this with an else. So I'm going to type in else, again left brace, press return, the right one appears. I'll put system.out.println and then type in these variables do not match. Okay. So 8 is there, 6 is there. That's a false condition. Instead of this executing, it jumps straight to the else, and this line will be executed. And there you go. So when that resolves to false, the else kicks in. Basically means everything else, if that isn't true. Just a bit of a sanity check. If A is not equal to B, so that's the true case, will this resolve as true or false? Yeah, resolves as true. So that will run. There you go. So you can use any data type here. You can go for a double. Let's change the values a little bit. So let's go for 8.6 and 6.9. And we'll go for if A is greater than or equal to B. Is that true or false? Yeah, that condition is true. So we should get the first 2 lines here executing. So anything within these first braces. There it is. So next time what we'll do is we'll look at compound conditions. So compound conditions are essentially a way you'll have more than one test within an if statement. So you might have that one, but then you might have a second test, a third test, a fourth test, and so forth. So see you in the next video. Hello. So this video is about extending an if statement to include more than one condition. So at the moment I have here a simple if statement, an if-else statement, that has one condition. And the point of this particular if statement is to see whether I got a particular drink, which is Fanta. If I do have Fanta, then I can drink it. If I don't, then I go to the shops. So I've set up a string variable, and I've initialized it for value of Fanta, making sure that I use speech marks because it's a string, of course. And then I'm saying if the condition that drink is equal to Fanta is true, then I can get drinking. Otherwise, then I need to visit the shops, go to the shops. So I want to, maybe, I don't know, maybe I can drink more than Fanta. I'm happy with Fanta, but I'm also happy with a delicious lilt, pineapple and grapefruit lilt, very Moorish beverage. So as long as I have a Fanta or a lilt, then I can get drinking. So what I'm going to do here is put in another condition. I'm going to use the OR logical operator. The OR, of course, means that either side of the operator can be true. If either side are true, then the output is true. So if drink is equal to Fanta, or drink is equal to lilt, then I can get drinking. So in this case, either that side of the operator is true, or that condition on the other side of the operator is true. If either of those are true, then the code within the braces will execute. And there we go. Now if it turns out that I've got only Dr. Pepper in my cupboard, then neither of these conditions are true, and we'll end up jumping to the else statement. There. Okay, so that's the OR. Now it might be that I want to drink as well, but I need to know if I'm thirsty or not. So I could set up a boolean, call it thirsty, and I'm going to just initialize that for value of true. Now it could be that I need to be thirsty and I need to have a lilt in my cupboard to drink. Now in this case, this is not an OR. We're not saying if you're thirsty or you have a lilt in your cupboard, you're going to drink. We're saying that both need to be true. So the symbol for that is the and, if you remember from the logical operators. So we need to put one condition on the left-hand side of the and one condition on the right-hand side. So the left-hand side condition is going to be, is thirsty equal to true? Okay, so if it is, we're halfway there. And is drink equal to lilt? Again, making sure that we use these speech marks here. Okay, so you can't just put lilt like that, because Eclipse will assume that this is a variable somewhere. So just make sure we've got speech marks either side. So this condition here and this condition here must be true for this line of code to execute. So they are, which gives us get drinking on our console. But if I change drink to Red Bull, only one condition is true. So which one's that? It's the left-hand side. Thirsty is still equal to true, but drink is no longer equal to lilt, because it's and. Both have to be true for this to execute. So we're going to get this go to the shops in our console. Same deal, if I put lilt back in here, and I'm no longer thirsty, so I put false, it's still not going to run because both aren't true. But if I go back to my OR, one side still works, so this side still works. So we're going to get drinking in the console. Quite difficult to explain. I hope you've understood it. If not, go over the video again and look at the individual parts. Best thing to do with this, though, is just to write some of your own if statements, to make up your own little scenarios, just like this one. Test it, change it, use different operators, and see how that changes the output. Okay, so give that a go and good luck. So the point of this video is to explain what an else-if statement is. So in previous videos you've looked at if statements, and here's an example on here. So the point of this if statement is to test the value of animal, and if it happens to be dog, then we execute this line of code, which will print to console, I have a dog. So if dog appears there like that, so if animal is set to dog, then I have a dog appears. However, if we have, say, cat, nothing will appear on the console. Now I could put an else statement in there and put system.out.println I don't know this animal. And of course that would be printed on the console there. Well, that's fine, but we might want to extend this if statement to include other animals. So we might want to say, if animal is a dog, then we print I have a dog. Else, if animal is a cat, we would print I have a cat. Else, if animal is a bird, I have a bird is printed. And for everything else we can put I don't know this animal. Well, turns out we can do that. So for now I'm going to delete the else and type in else if. Then I can add another condition. So I can put animal equals cat. So animal is equal to cat. If that condition is true, then I'm going to print out system.out.println I have a cat. Okay. So at the moment we have animal set to cat up here as a string. This condition therefore is true. This one is false. So this won't run. But this one's true, so this should run. So check the console out and see what happens. And I have a cat appears at the console. Again, we can extend this, so if I else if once more, parenthesis again, animal is equal to bird, and I could print out I have a bird. So if it turns out that animal is a bird up here, then of course I have a bird on the console. So just to unwrap this a bit more then. So we start at the top. If animal is equal to dog, you would execute that line of code there which says I have a dog. Well, that condition's false. So the if statement moves on to the next part, the else if the condition animal is equal to cat. Again, that's false. So it moves on even further until the point we get to animal is equal to bird. That's true. So this is executed. We can still end with an else at the end. So if our string animal is equal to not dog or cat or bird, then we can still put I have no idea what this animal is. So there you go. So what we've done then is extend our if statement to have more than one condition. So we can have one, we can cascade to a second, a third, a fourth, as many as you want. So we have lots of different conditions which will print different things based on what our original string value is. Thanks so much. Hi folks, so this is the last in our kind of mini series of if statements. So we've covered if, a basic if, we've covered compound conditions, and we just covered else if statements. And this one is going to be about nested if statements. So what I've got set up already in Eclipse here is a simple combination lock. So this combination lock has two numbers that need to be solved, denoted by these particular variables. So the first one's number 1, so that's the first number that needs to be solved, and then we've got an int which is number 2, which is the second number that needs to be solved. And the if statement is quite simple here. It's using a compound condition, which is saying if number 1 is equal to 5 and number 2 is equal to 8, then we've opened the lock. Else or otherwise, there is no access. Okay, so this will work, of course. So if we have the same numbers as which we've set here, so if this is the secret number, the first secret number is 5, the second secret number is 8. If we get both correct here, then of course the lock will open. If we get one of them wrong, then the lock will remain closed. Same over here. Okay. The problem is here, we have no feedback to tell us if we have, say, the first number correct, but the second number incorrect, or vice versa. So we can solve this. We can solve this problem by using what's called a nested if. So let's take the first number. If I delete some of that, let's just work with the condition. Now I'm going to just take away most of that stuff for now, like that. Let's work with the first condition, that number 1 is 5. So if it turns out that we get that correct, we could print system.out.println. You have the first number correct. And once you've got the first number correct, then you can test the second number. Now, instead of writing a separate if statement underneath this initial if statement here, we can incorporate it into the first one. So as we know, between the braces is the body of code that is executed if this condition is true. So we can execute a second if statement if that first number 1 condition there is true. And that's what we're going to do. I'm going to type in another if. I'm going to say if number 8, if number 2 is equal to 8, braces, then system.out.println the lock is now open. Okay, so let's just go over that again. So we're saying that if the first number is true, so if that condition is true, so indeed number 1 is set to 5, then it'll print out you have the first number correct. And then if you happen to have the second one correct as well, then the lock will open, because of course then we'll have solved both number 1 and number 2. Okay, so both conditions are true there and the lock will open. Now we could say here, I could put an else in this inner if statement and put else system.out.print. You have the second number incorrect. So then if it turns out that I got the first number correct, that would be true, but this would be a false statement. So this wouldn't execute, but this line here would execute. And there we go. So if the secret numbers are 5 and 8, in this condition, we got the 5, but we didn't get the 8. And that is why you have the first number correct in the console, but you have the second number incorrect in the console. Now it might turn out that the first number is incorrect. But if it is, we can extend this outer if statement, which note ends there, with another else. So I can put else. You have no numbers correct. Okay, so we pretty much dealt with all conditions here. So the condition where we got the first number correct, but we got the second number incorrect, which would be that line that's executed, or if we got the first number correct and the second number correct as well, we would have the lock is now open. But if we didn't even get past the first number, so if we got the first number incorrect, say if we went for 3, then we'd jump down to this else, and that line of code would execute, telling us that we have no numbers correct. So try and code this example, work it out, unpack it, take it slowly, and see if you can figure out all these different stages within the nested if statement to produce this combination lock. Have fun! It's Sunday, it's 4:30, and all my days, it's time to learn about switch statements. So I've got on the screen at the moment an else if statement with lots of different conditions. And the point of this statement is to test different types of weather. So if the weather is sunny, take some sunglasses will appear on the console. If weather is set to rainy, then take an umbrella will appear. If weather is set to windy, take a coat will appear on the console. If weather is set to snowy, take snow boots will appear, and so forth. So at the moment, windy is what our variable weather is set to. So that will not be true condition. This will not be a true condition, but this one will be. So we should get take a coat to the console. And there it is. So there's nothing wrong. There's nothing technically wrong with what's happening here. The only real problem is it's quite difficult to read. And we tend to find where there are lots of else ifs and lots of conditions within an if statement, we can use a switch to make it easier to understand. So the point of this session here is to what we call refactor or rewrite this code using a switch statement to make it easy to read. So I'm going to do that. So for now I'm going to comment out this. We'll keep it there so you can actually see how the parts of the switch statement correspond to the if, but we don't want this particular section of code to actually run. But we do need the weather still set at something, and we can keep it to windy at the moment. So the switch statement is going to begin with the word switch, and then we're going to have some parentheses. And within those parentheses, we're going to put the variable in which we want to test. So this is going to be weather. So I'm going to just paste weather into there. Then you will need an open brace, hit return, and the closed brace will automatically be generated. So this is very similar to an if at the moment. Now a switch works with cases. So it might be the case that the weather is sunny. It might be the case that the weather is rainy. And it might be the case that the weather is windy. So these are the cases we're going to deal with. I'm going to type in case. And then I'm going to put my first case, which is the case that weather is sunny. Again, remembering that because we're dealing with a string, we need speech marks around the possible case. Now at the end of that case, we're going to encounter a colon. Now colon is something we actually haven't used in code so far. So when you see a colon, you're probably going to expect to see a switch. So then I'm going to hit return. And then I'm going to type in the code that I want to execute if it is the case that the weather is sunny. So I want to go for this print statement here. So system.out.println, take some sunglasses. And then I'm going to split my case. So I'm going to finish my case with a break. Now I'm going to explain what a break is in a moment once we've put all the cases in. But for now, this will identify the end of this case. Then I hit return. Now I can put my second case in. So if it is the case that the weather is rainy, colon, then I'm going to print to console the words take an umbrella, like so. And again, to finish the case, we hit break and return. Third case might be the case that the weather is windy, colon, and let's go for take a coat and break. The final case, because of course in our original example we got 4 cases, 1 sunny, 1 rainy, third condition is windy, and the fourth condition is snowy, so we can make a case for snowy too. So case snowy, colon, and I'm going to print out, if that's the case, take snow boots, and a break to finish. So hopefully so far you can see how these cases refer to these conditions. So this first if, which is testing sunny, to print out take some sunglasses, is essentially this here. So the test is it the case that the weather is sunny? And if it is, this code will execute and so forth. So that's all good, except we don't have an else at the moment. We don't have a condition where, you know, if it isn't sunny, if it isn't rainy, if it isn't windy, and it isn't snowy, what actually happens? Well, we can do that. We can type in the word default. So default won't have, say, any text here because we don't know what it's going to be. It's going to be everything else except for the 4 cases that we've defined above. So default and then colon, and then whatever we want to be printed. So system.out.println, I don't know this weather. And then just for completeness, or you don't actually need to do this, and you'll see this in a moment, is to stick a break at the bottom. So if I change the variable weather to, say, snowy, in the original if statement, we'd expect to see take snow boots. And in our switch, refactoring, we'd expect to see take snow boots as well. So I'm going to run the code, and there you are. Take snow boots appears in the console. So let's try a default condition. So we need weather to be something which isn't sunny, isn't rainy, isn't windy, and isn't snowy. So if we go for something like hot, there, you'll find that none of these cases resolve as true. So that's not true, that's not true, that's not true, that's not true. But so we end up running the default case, which should give us I don't know this weather at the console. And there it is. So what is the deal with the break? Well, the break does 2 things. Firstly, it splits up our cases into individual cases like that. But secondly, it tells the compiler to stop running the case as soon as we get to it. So, for example, if we have sunny here, okay, we'd expect this case to run. So naturally, this line of code would execute. We get to the break, and then we jump to the end there. So if you imagine my cursor is the Java compiler, it'll read that, it'll know it's a switch, it'll find the case, it'll execute that code, it'll hit a break, and it'll jump all the way down to the end of the switch statement, and then, I don't know, anything could happen down here, another if statement, or who knows what you want in the code. Okay, now if you didn't have that break, what would actually happen is, sure, this print statement would execute, but then the compiler would jump to the next case. So in fact, actually this print statement would also execute. So just to show that, there you go. So that one runs, and then doesn't jump to the end, goes to the next case, executes that one. So if I was to comment out the break on the rainy case as well, then the windy case would also execute, giving us take a code in the console. So it's really important that we keep those breaks in there. So hopefully you'll have noted that the switch is very similar to the if statement, but possibly quite much easier to read, especially if you have lots of different cases. The other thing to note actually is it's quite easy to extend. So if I put another case for hot, I could easily just get some of that. So wear a t-shirt, say. The crucial break at the bottom. Hot goes up there. There you go, wear a t-shirt. So it's really easy to extend. You can have lots of different cases, and you can quickly scan through them and see what the result would be if any particular case happens to be true. So there's some excellent examples on Minerva for this. One particularly good one is where the number of a month will be tested, and depending on what the number of the month is, so if it's 1 or 2 or 3 or 4, the name of the month will be printed to console. So have a go. Try refactoring some of your else if statements to switches and have fun. It's time. So it's time to tackle that thing that a lot of people who are new to coding really struggle with, and that's loops. So we're going to do about 4 or 5 different videos that are going to look at different looping techniques, including the while loop, the do while loop, the for loop, and also selecting which loop is best for any particular application. So why do we use loops? Well, generally, if you find that in your program you have a lot of repeated code, for example here, where you might only have one parameter which changes on each line of code. For example, in this program here, we print in the numbers between 1 and 12 on separate lines. Each line of code is pretty much the same, but the only thing that we're changing is the number that's being printed. Of course, that gives us 1 to 12 in the console, like that. If you wanted to print out, say, 1,000 numbers, that becomes quite tedious because you'll just have to keep repeating and repeating and repeating, changing the numbers each time. And just to get a print out of 1,000 numbers, you need 1,000 lines of code. Not very efficient. So we could refactor this code here, this program, using a loop. So it should end up taking, say, 12 lines of code and doing the same job with only about 5. So we can do this with something called a while loop. So you'll notice here that we start with the value of 1. Well, I'm going to begin by setting up an integer. So I'm going to declare an integer. I'm going to call it count, and I'm going to initialize that with a value of 1. Now, I'm going to write this in and then explain it. So I'm going to type in while. In the parenthesis, I'm going to put count is smaller, so it's less than or equal to 12. Some braces, and then I'm going to put system.out.println count, then count plus plus. There you go. Okay. So what I've done here is essentially refactor that code into a loop, which is going to do the same job. So just explain parts of it then. Now there are 3 stages to any loop, and the first one is the initial number. So we're starting with count of 1, just like in this first line of code here. We're then basically saying, while it is the case that count is smaller or equal to 12, then we're going to print out the value of count, and we're going to increment it by 1. So you've got 3 components. the initial value, how much the value goes up each time, and when that loop should stop. So if I get rid of this or just comment it out, run the code, you have the same result. Now this is great because I can put something like 500 in here and it'll print all the way up to 500. So you can see this is quite a powerful little system. We've got three particular components. So starting value, how much we want to increase by, so this is called the increment. And then this, which is called the range, is basically for what conditions will this loop continue to loop. So if I change this to 10, we can break this down even further. So essentially what's happening on the first loop, so we call this an iteration, so the first iteration of this loop, count will be the value of 1. So we look at this condition, we think, well, is that true? Well, 1 is less than or equal to 10. It is true. So this next piece of code within the body, which is indicated by these braces, will execute, and this line of code will execute. We know count plus plus basically means add 1 to count, so count becomes 2. So at this point, count is 2. We loop back round, count is 2, so 2 is less than or equal to 10 is again a true condition. This runs, this executes, count becomes 3. Go around again, count is 3, so 3 is less than or equal to 10, again is true. So this executes all the way up to the condition where count is 10. So a count is 10, that is still true, so 10 is less than or equal to 10. So this line of code executes, this line of code executes, and we end up with count is 11. Now, the while loop will try to loop once more. Count is 11 at this point. Now if count is 11, 11 is no longer less than or equal to 10. Hence all these red marks. So what happens is we leave the while loop and continue with our code. So, you know, there might be a system.out.println here that says this is the end of the loop. Okay. So here, start at 1, increment 1 each time, loop around as long as count is less than or equal to 10, and when that condition is no longer met, then we carry on past the loop. So you should see this time that we get a printout from 1 to 10, and then we'll get a printout of this is the end of the loop in the console. And there it is. So we don't have to count up all the time, we count down, so we could start with a value of 10 there. We'll leave that bit for the moment, but we'll put minus minus here, indicating that we want to remove 1 from counter each time. Now basically, what we're saying is we want to count down to 0. So if we want to count down to 0, then the loop will only continue, only iterate as long as count is bigger or equal to 0. So just to be clear, count begins at 10. So 10 is bigger and equal to 0, that's fine. So we run that line of code there. So we print out 10 in the console, then we take 1 away from count, count becomes 9, loops round, 9 is larger or equal to 0, so again the same thing, until the point we get to 1. So if count is 1, 1 is still greater than or equal to 0, so we get the printout, we minus, 0 still works, but as soon as count decreases from 0 to minus 1 is no longer greater or equal to 0. So of course this while loop finishes and you get this is the end of the loop at the end of the console. So if I run it, you can see that doing exactly that. We can increment by different amounts, so if I don't want to go down by 1 each time, I could go minus equals 2. These should be familiar statements here. Go down by 2 each time, could go down by 5 each time. It doesn't matter. Okay, so that's a rough introduction to the while loop. I'm going to do a slightly more complex example in the next video for you. Bye. Okay, welcome back. So in the last video we looked at the anatomy of a while loop. So we used this example which counts from 1 to 10, prints each number on the console by incrementing by 1 each time. We broke that down into 3 stages. So initially we begin with a value of 1, so we declare a variable called count, set that to 1, initialize that with a value of 1. We count up each time through the loop by adding 1 to the value of count. And we do that as long as count is less than or equal to 10. When it's the case that count is not less than or equal to 10, say if count becomes 11, then we leave the loop and carry on with the rest of the program, which will of course print this is the end of the loop. So just to recap, that's what happens in the console there. So what we're going to do this time is look at a more advanced, a real world, I guess, implementation of this loop. So what we want to actually do is create a combination lock breaker. So this is quite an advanced lock. It's got 3 stages. The first stage requires a number between 1 and 1,000. So does the second stage, and so does the third stage. If we identify all 3 of those numbers, then the lock will unlock. Now the secret combination that we have here is 565 for the first lock stage, 789 for the second lock stage, and 124 for the third lock stage. So we're going to try and build that scenario and solve that code problem within Java. Okay, so we can use simple while loops for this. Now, really, the key thing here is for us to begin with the, say, if we just look at lock stage 1, is to begin with the value of 1 and just keep adding 1 each time until the point we get to 565. Okay, so let's try and do that. Let's get rid of this code and let's begin by putting in our secret numbers first. So the actual numbers we need to break the lock for each stage. So these will be integers, of course. So let's go for lock stage 1 here. Set that to a value of 565. Same for lock stage 2. And we set to a value of, completely forgot what it is, 789. And lock stage 3, which is 124. So these are secret numbers. So if you're building this application for a user, they wouldn't see these numbers. They would just see the output we're trying to generate here. So we're going to try and crack that first stage of the lock. So to do this, as mentioned before, we begin with a value of 1 and just add 1 each time until we get to 565. So that means then that the loop will continue to loop as long as the value of the variable that we're increasing is not the same as 565. So firstly, we need a variable that we can use to count up. So we call it count1, and we start at 1 because that's the logical first number to begin with. If we want to find out a number between 1 and 1,000, we're not going to start at 500 because we'll be missing out 1 to 500. So we begin at 1, and then we can implement our while loop. And we're basically saying here that as long as count1 is not equal to lock stage 1, then we'll add 1 to count1. Okay, so when count1 is 1, 1 of course is not the same as 565, so we add 1 to count1, it becomes 2. 2 is not the same as lock stage 1, so we add 1 again, becomes 3, so on and so on until we get to 564. So 564 is not equal to lock stage 1 is still correct, still true, so we add 1 to count1 again, and then we get to 565. Now at that condition, count1 is 565, is not equal to lock stage 1, which is also 565, becomes a false statement in that condition there. So we leave the while loop and continue on with our program. Now that's good because count1 is then set at 565. It doesn't increase anymore, it's not going to decrease, it's not going to change. It's there, it's hanging there ready to be used later on in the program. And you'll see in a moment we're going to print that value out and it should say 565. So that's stage 1. So stage 2 is the same sort of deal really. We use a different variable name this time because otherwise it's going to conflict with that first one. So we're counting up again, between 1 and 1,000, trying to find that secret number 789. So we start with 1, implement another while loop. Same sort of deal really, as long as count 2 is not equal to lock stage 2, we continue to loop, and we continue to add 1 to count 2. So same thing, we get to 788, count 2 becomes 788, 788 is not equal to 789, so we add 1 again to count 2, then it becomes 789, 789 is not equal to 789 is a false statement, so we leave the while loop and continue on the program. And that's where we try to solve lock stage 3. So we'll call this one count 3, begin at 1 yet again, another while loop, count 3 is not equal to lock stage 3 and count 3 plus plus. Exactly the same thing. We get to 1, 2, 3 here. 1, 2, 3 is not equal to lock stage 3 is true, so the code within these braces runs, it executes, meaning that count 3 then becomes 1, 2, 4. 1, 2, 4 is not equal to 1, 2, 4 is false, so this line of code will not execute, so count 3 will remain at 1, 2, 4, and we'll carry on with the program. So at this point then, these 3 while loops should have identified these numbers. So count 1 will remain at 565, it won't loop any further. Count 2 will remain at 789, again, won't loop any further than that. And count 3 will remain at 1, 2, 4, it doesn't increment any further than that. And the last point of the program is simply to print out our values of count 1, count 2, count 3, and with any luck they should be the same as the secret lock numbers. So system.out.println, let's put the first secret number of our lock is space, and then plus, because we're concatenating, we want the number to be at the end of this sentence, count 1. Which hopefully should be, which a value of 565 should be stored in count 1 right now. Do the same for the second number. And the same for the third number. Okay, there we go. So these print on different lines. So we should see in the console here, the first secret number of our lock is 565. The second secret number of our lock is 789. And the third secret number of our lock is 124. Fingers crossed, and there it is. So try writing this down yourself, try changing the name of some of these variables so you can understand that these are just really holding values for us to count up, that's all. Change the numbers, you'll see that the while loop still identifies the correct secret numbers. Great thing about this, that this whole program executed in, well, less than 1/10 of a second. So this while loop did 565 loops or iterations. This second one did 789 loops or iterations, and this third one did 124 loops or iterations. So that's a lot of calculation in less time than it takes to blink. Check it out, make sure you understand it, and we can move on to do while loops on the next video. Good luck. So in the last video we looked at while loops, and in this one we're going to look at something called a do while loop. Now the do while loop is pretty similar to the while loop, but there's a slight difference in its operation. So at the moment I've got a simple while loop on the screen here. So I've initialized, I've declared an integer called count and initialized it with a value of 1. And then I've set up a while loop, which essentially tests the value of count. And it says if it's larger or equal to 5, then we're going to print that value in the console and then increase the value of count by 1. Now, the keen-eyed people among you will notice that count is never going to be greater than or equal to 5 because it starts at 1, making this condition false And of course, these 2 lines of code will never execute. So if I run the program, nothing will appear on the console. So the order of operations in this while loop is this. We do the test. So we test this condition here. If that evaluates to true, then the code within these braces will execute. Now a do while loop is slightly different in that the code between the braces will execute and then the test will be carried out. So in the do while example, so if I just comment that out for now, count will be printed to console. So at the moment count has a value of 1, so we should see 1 in the console. Count will increase by 1, making it 2, and then this test is carried out. Does this test evaluate to true or false? It evaluates to false, because count is 2 at that point. 2 is greater than or equal to 5 is a false statement. So of course this loop will not continue. So it won't go back up here, it won't print out count again, it won't increment by 1, it just carries on down the program to do whatever else we want it to do. So let's just try that. So if I run the program, 1 will be printed to console, technically count becomes 2, that test is carried out and nothing else happens. So that's slightly different to the while where we do the test, that becomes that evaluates as false and this code is not executed, so nothing appears on the console. So you might ask yourself, what is the point of using a do while loop instead of a while loop? What kind of scenario might we have that we need to run a bit of code before testing a condition? Well, it turns out that's quite a useful thing to do when we're creating text-based games. So in this text-based game, there's some kind of user input, there's a question. So the question we ask is, what is 1 plus 1? And then we accept an answer from a user as an integer. So down here I could type the answer 3, if it's incorrect. That answer is stored to the variable user input. And then we test to see whether user input is or isn't equal to 2. If it's not, we iterate the loop, do it again, ask the question once more, get another answer off the user, and test again. So this will keep happening again and again until user input is 2. At that point, this becomes a false statement, and the while loop, the do while loop, will essentially cease, and this next line of code will execute here, which says there's the correct answer. So we're using something called the scanner class to do this. Now what all scanner does is it accepts user inputs. And in this case, we're interested in a user input, which is an integer. Don't worry too much about scanner. We're going to look at this in another video. Just note that this line of code here is essentially saying, stick an integer into the console and I'm going to save it to the variable user input so we can do something with it. So if I run this example, of course, what is 1 plus 1 appears on the console because that's what we expect it to do. There's no test first, so that happens straight away. I'm going to put the answer 3, an incorrect one. Hit return. 3 appears here. 3 is not equal to 2 is a true statement, so that condition resolves as true. So the loop will iterate. So the question is asked again, and there it is. So if I put 6, again an incorrect answer, it loops around. Put 8, an incorrect answer, loops around. If I put 2, this then becomes a 2. 2 is not equal to 2 is false, that evaluates as false. So the loop exits, and this next line of code executes. So if I hit return here, that is the correct answer appears on the console.